Hello students, hope you all are fine. My name is Gurinder Pal Singh and in this video we will discuss about the graphical representation of motion. We will study different types of graphs. We will study equations of motion by graphical method. So students, graphs provide a very easy method to present basic information about lot of events. For example, in the telecast of one-day cricket match, vertical bar graphs show the run rate of a team in each over. In mathematics, a straight line graph helps in solving a linear equation having two variables. Now we will discuss about the distance time graph. In this graph, time is taken along x-axis and distance is taken along the y-axis. If we look at the markings carefully, we observe that when time is 42 minutes, then distance is 28 kilometers. And when the time is 56 minutes, then distance is 38 kilometers. So we can say that there is an equal increase with equal intervals of time. This shows the distance covered is directly proportional to time, that shows bodies moving with uniform speed. Now if we look at this graph is not a straight line. And if we look at the markings carefully, we observe that when time is 2 seconds, distance is 1 meter. And when time is 4 seconds, distance is 4 meter. When time is 6 seconds, distance is 9 meters. So the nature of this graph shows non-linear variation of distance. This graph represents motion with non-uniform speed. This is the distance time graph for a stationary object or a body. A stationary object does not change its position with time. It means the distance of the stationary object remains same from the reference point with the passage of time. Now we will study the velocity time graphs. Velocity time graph for the uniform motion of a body is a straight line, that is AB, which is parallel to the time axis. I would like to give you very important information regarding this is that velocity time graph represents that the area enclosed under graph gives the displacement. In this, body is not changing its velocity with respect to time, that shows that body is moving with the same velocity. Like, if we take the markings on the x-axis, we see that in any time, the velocity is exactly the same. The information that we get is, the body is moving with constant velocity. Displacement is equals to area under velocity time graph. So area is equals to length into breadth, AC into CD. So this area of rectangle ABCD, that is a shaded part, is the displacement. So the area of this rectangle represents the displacement. Students, we can also find the distance moved by the car from its velocity time graph. The area under velocity time graph gives the distance or the magnitude of displacement moved by the car in a given interval of time. If the car is moving with uniform velocity, the distance traveled by it will be represented by area ABCDE under graph. This structure ABCDE consists of area of rectangle ABCD and area of triangle ADE. We know that the formula of area of rectangle is length into breadth and area of triangle is half of base into height. We will simply apply the formula, substitute the values and we will get the result. In first graph, the velocity time graph that represents the motion of an object whose velocity is decreasing with time. And second graph shows the velocity time graph representing the non-uniform variation of the velocity of object with time. Next topic that we will start is equation of motion by graphical method. We will derive these three equations of motion. Here, u is the initial velocity, v is the final velocity, a is acceleration, t is time, and s is the distance. Now we will start with the first equation, that is equation for velocity-time relation. We will consider that object moves under uniform acceleration like this graph. Students, look at this graph very carefully. Time is along x-axis and velocity is along y-axis. Initial velocity of object is u, that is at point A. This is the graph of the motion of object. Final velocity is represented by v. The velocity changes at uniform rate A. Draw a perpendicular line BC from point B on the time axis. Draw a perpendicular line BE from point B on velocity axis. Initial velocity u is represented by OA. Draw AD parallel to OC. So OA is equals to CD. So initial velocity u is represented by both OA and CD according to the graph. Final velocity v is represented by BC and BC is equals to OE. Time interval t is represented by OC. BD is equals to BC minus CD. This represents the change in velocity in time interval t. We will split BC into two parts. BC is equals to BD plus DC. BD same and DC is equals to OA. And we know that BC is equals to V, OA is equals to U. We will simply substitute the values in the above equation. We will find that BD is equals to V minus U. Now we will use the formula acceleration is equals to change in velocity upon time. Change in velocity is equals to BD, time taken is equals to AD. And from the graph we know that AD is equals to OC. And we know that BD is equals to V minus U and OC is equals to T. On simple rearranging the terms, we will get a result. And this is the velocity time relationship. V is equals to U plus AT. Hope you are understanding this. Next we will do equation for position time relationship. Suppose that object has traveled a distance s in time t under uniform acceleration a, and we have studied earlier that area under velocity time graph represents the distance. So this is the area under line AB. This is actually the trapezium, and we will split this trapezium in two pieces. First one is rectangle and second is triangle. We will use these two formulas, as you know very well that area of trapezium is equals to area of rectangle plus area of triangle. This is the length of the rectangle and this is the breadth of the rectangle. So area of rectangle is length into breadth, that is equals to OA into OC. In triangle ABD, AD is base and BD is height. Here we have used the formula of area of triangle, that is half of base into height. From the graph we have concluded that CA is equals to U, OC is equals to AD is equals to T. And we have concluded BD is equals to AT from the first equation of motion. Now simply substitute all the values in the above equation. We will get our result. So result is S is equals to UT plus half AT square. This is the position time relationship. Now we will study about equation for position velocity relationship. In a similar manner, distance is equals to area of trapezium OABC. Here we will use the formula area of trapezium is equals to half of sum of parallel sides into height. We will apply this formula to this trapezium. OA and BC are the parallel sides of the trapezium and AD is the height of the trapezium. So we will apply the formula of area of trapezium over here. From the graph, we have concluded that CA is equals to U, BC is equals to V and OC is equals to T. We will simply substitute the values and get this. Now, recalling the very first equation of motion, that is V is equals to U plus AT, on simple rearranging the terms, we will find the value of T. So this is the value of T which we have derived now. Now, put this value of T in the above equation, we get this. Now we will apply this formula over here and on simple rearranging, we will get a result, that is V square minus U square is equals to 2AS. These are the questions related to the topic. Hope you like this video. Thank you so much, students.